Okay, today we are going to be talking about chemical reactions. Biochemical reactions are just chemical reactions that occur in the body. Some of the ones we're going to talk about as examples today won't necessarily be ones that take place inside the body or inside living things, but they make for easy examples for us to understand what it is that we're talking about today. Okay, so review quickly. What is a chemical reaction? So we have reactants on one side of this arrow, which we call the yield sign. It's like an equal sign. And we have products that occur on the other side. So we take the reactants and they react, and then we end up with some products. Just know that there could just be one reactant that breaks down into multiple products. So it doesn't have to be plural on this side. So a chemical reaction, this is a process where substances chemically change into different substances. Really good to keep that in mind. Important to realize that in order for it to be a chemical reaction, we have to start out with certain substances and end up with different ones. This means that bonds are broken between the atoms in the original molecule, and then new bonds are formed to make the new molecules. So we see on this side of the equation, we have this one carbon atom, and on this side of the equation, we also have just one carbon atom. And that's kind of what we're going to be talking about today, is keeping track of all the atoms on both sides of the equation. So there are two different types of chemical reactions that we're going to talk about today, endothermic and exothermic. And we've been talking a little bit about this in class already. So reactions that release energy into their surroundings are called exothermic chemical reactions. And so combustion, burning something, rusting, and fireworks, which technically is combustion, but much cooler, right, is also considered an exothermic chemical reaction. So energy is being released, and oftentimes that could be heat energy as well as light energy. And then reactions that absorb energy are called endothermic. So these ones are going to decrease in temperature compared to their surroundings, photosynthesis. And then baking soda and vinegar is also a really simple endothermic chemical reaction. All right, so be careful because some processes can be endothermic or exothermic, but do not qualify as a chemical reaction. So melting ice is what we call an endothermic process because heat is being absorbed, but no chemical reaction is actually occurring. You still have water at the beginning and the end, right? So we haven't changed the substances at all. Water at the beginning, water at the end, not a chemical reaction, but is an endothermic process because it's absorbing energy. Okay, photosynthesis, we talked a little bit about how this is an endothermic chemical reaction. So this is the chemical equation for photosynthesis. So plants, as we know, absorb carbon dioxide from the air around them. They absorb water through their roots, and they absorb sunlight energy. So this is the endothermic part, right? To do this photosynthetic process. And when they do that, they create glucose, and they release oxygen back into the environment. So that is our process. There is a reverse process called cellular respiration, which is exothermic. This is where humans do this as well. We can't do the photosynthesis part, but plants do both photosynthesis and cellular respiration. Humans just do the cellular respiration. We eat glucose. Plants use it because they've made it. We breathe in oxygen. And then we create ATP from that, which is a type of chemical energy that can be used to get the body to do things. Plants use it for plant growth. And heat is also a byproduct of that process. And then we breathe out carbon dioxide and water. And so this is a reverse process of photosynthesis. Exothermic on this side, endothermic on that side. Okay, so one of the concepts that was covered in the CK12 reading is the law of conservation of mass, which basically states that matter cannot be created or destroyed. It can only be transformed into a different type of matter. So this is going to come up as we start talking about chemical equations. So simplified version of thinking about conservation of mass is we take a log and we burn it, we may end up with some ashes that feel pretty light, but we have to take into consideration that there actually is some mass in the smoke that is created. And so overall, we end up with the same amount of mass before and after the fire. So let's take a look at what that might mean in terms of a chemical reaction. Well, that means that our chemical reactions need to be balanced. So by balanced, we mean that on the either side of this yield sign, we have to have the same number of atoms. We can't just make new atoms from nothing. And we also can't just magically make atoms disappear, right? Conservation of mass, law of conservation of mass says matter cannot be created or destroyed. So if we have a carbon atom before the chemical reaction, then we have to have a carbon atom after the chemical reaction. If we have 4 hydrogen atoms before the chemical reaction, then we have to have 4 hydrogen atoms at the end. And then the same is true for our 4 oxygen atoms and our 4 oxygen atoms. So this is an example of a balanced equation. So that's what we're going to be learning how to do today. We're going to be learning how to balance equations. So just a review of some of the numbers that you're going to see in the different chemical formulas that will be found on either side of the yield sign. So coefficients, these are the big numbers that occur up front, right? So this large 2. This tells us how many of these molecules are present on either side of the equation. The subscript is the smaller number that tells us how many of these atoms are found in this molecule. Now, the rules are you are only ever allowed to change the coefficient. You can change the number of this molecule that occurs on either side of the equation, but you're not allowed to change the subscripts, because if you changed the subscripts to something else, you've completely changed this molecule. And what you're saying is, oh yeah, this chemical reaction didn't really involve this molecule, it involves some completely other molecule, which is not true. So you may never, ever, 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 ever change the subscript in your equation. You may only change the coefficient. And then remember that subscripts of 1 or coefficients of 1 are never written. It's just understood. So if there's not a number after the atom, or there's not a coefficient up here, then it's just understood that it's a 1. You don't need to write it. Okay, so this is a really important set of rules. Only change the coefficient, never change a subscript. Okay, so a few more rules, and then we'll start practicing. I am always going to give you the molecules that will be present on both sides of the equation. So you don't have to figure out what molecules get created from these molecules. I'm always going to give that to you. So that means you already know the products and you already know the reactants. You don't need to figure those out, okay? What you don't know is how many of these different molecules are present on both sides of the equation, okay? So that means that you can change the coefficients of any of the molecules within the equation in order to balance the equation. But as I said before, you're not going to change the subscripts, okay? So if we were going to balance this particular equation, we want to take a look at how many of each atom there are on both sides of the equation. So here we have 1 oxygen, and here we have 2 oxygens, but on this side of the equation, we only have 2, which means we're not balanced. Our oxygens are not balanced. And remember, we have a 1 understood in front of each of these. So if I have 3 on one side and I have 2 on the other side, I don't really have any choice but just to bump up my coefficient from a 1 to a 2. So we're just going to give that a try. We're going to say, okay, it's a guess and check process. If I put a 2 here, remember this 2 now is going to apply to all of the atoms in this molecule. So now I have 2 carbons and I have 4 oxygens, right? Because this little 2 means I have 2 here, and now I have 2 sets of this molecule. So there's a total of 4 oxygen. So now I come back to this side. Since I have 2 carbon here, I need to have 2 carbon here. So I'm going to go ahead and put a 2 there. Remember, it's just guess and check. We're going to put a 2 there and see how we did. So I have 2 carbons now, and now I have 2 oxygens here, and I have 2 oxygens here. So that's a total of 4 oxygens on this side of the equation. On this side of the equation, I have 2 carbons, and I have 4 oxygens. So I'm balanced. I don't need to do anything here. I can just leave that as a 1. So that's an example of a really simple balancing a chemical equation where we have carbon monoxide and oxygen reacting to create carbon dioxide. Okay, let's practice. At this point, when I go to the next slide, I want you to pause the video and then try to balance the equations on your own on a piece of paper and see how you do, okay? So here are some chemical equations that I'd like you to try to balance. So please pause the video now. Okay, so hopefully you've paused the video and you tried these out on your own. And now we're going to take a look at the actual answers. So if I pop these answers in here, we'll take a look at why the answers came out the way that they did. So I had a water molecule on this side with 2 hydrogens and only 1 oxygen, but I had 2 oxygens on this side over here. So I had to stick this coefficient of 2 on here just to get my oxygens to balance out. But because I ended up also changing the number of hydrogens, I had to add a 2 here. So now I have 4 hydrogens on this side, 4 hydrogens on this side. I have 2 oxygens on this side, and I have 2 oxygens on that side. So this equation is now balanced. All right, let's take a look at this one. I had 8 sulfur atoms here, which means I have to stick an 8 over here to make 8 sulfur atoms on this side. But this 8 is also going to apply to my oxygens. So now I have 24 oxygens on this side and just 2 on this side. So I'm going to stick the coefficient of 12 to create 24 oxygens on this side. And now this equation is balanced. Let's go to the next one. On this one, I have mercury and oxygen on this side. And on this side, I have 2 oxygens. So I've got to stick the coefficient 2 here to balance out my oxygens. And because I did that on this side, I now need to put a 2 here to balance out my mercury. So again, it's just a guess and check. You're going to figure out for one, and then you're going to see how it affects the others. All right, so on this one, I look at zinc. Zinc seems fine on both sides, so I'm okay there. And then I start to look at my hydrogens. I have 1 hydrogen here, but I had 2 here, so I had to add this coefficient. When I add the coefficient 2 in front of my hydrogen, it's going to affect my chlorine. And if I look over here at this chlorine, it already had a 2, so now I'm balanced. I only needed this 1 change in the coefficient. By the way, sometimes you might end up with an equation that's already balanced. So that happens sometimes. That might just be already balanced when you get it. Okay, last one. A little bit trickier. So as I started off, I probably start with the first one and I think that these guys are balanced. And then I get to my hydrogens and I start to see that my hydrogens are not balanced because I have a hydrogen here and I have 2 here. So it's 3 on this side. But when I come over here, I only have 2. I can't just add 1. My coefficient is 1. The only choice I have is to bump it up to 2. And when I bump it up to 2, I create 4, not 3, right? I had 3 on this side, but I can't make 3. I can only make 4, which means that I have to add the coefficient 2 here, which means now I have 4 hydrogens on this side and 4 hydrogens on that side. But because I added my 2 here, I also changed the number of sodium atoms. The Na is for sodium, which means I needed to add a coefficient 2 here. Okay, so hopefully that kind of made sense, especially if you did pause the video and work your way through it, because it takes some time and some patience and some perseverance to get good at balancing equations. But once you figure it out, it's actually kind of fun. So hopefully you did well. If you did not, or you don't feel like you have it yet, don't panic. We're going to get lots of opportunities to practice this skill in class. All right, that's it for today, folks.